Hello PLP Geometry. Welcome to video 7b, where we actually complete some proofs involving triangles, right? So again, our goal here is to prove triangles congruent using one of those 5 ways we discussed in video 7a. So again, Unit 2, congruent transformations and triangles. Video number 7b, we are proving triangles congruent. All right. Okay, so I have 3 proofs for you, right? So simple. We'll just go through these 3 proofs and see how we do. So example 1. All right. So we are given segment LM is congruent to segment LO, and we're given that segment LN bisects angle MLO. And here's our pictures. We have this segment here, we have this triangle up here, we have this triangle down here. So this is L, M, N, and this is O. And our goal here is to prove that triangle L, M, N, the top triangle, is congruent to triangle L, O, N, the bottom triangle. So I will set up our proof. I'm not going to put statements and reasons. I'm just going to put S and R. So there's my statements box. There's my reasons box. Okay, so we always start the proof off with our given. So in my first box here, I'm going to write down that segment LM is congruent to segment LO. And I'm going to put that segment LN bisects angle MLO. And that is given to me. And that all comes from right up here, the given. So let's go to mark that, right? So in this picture, LM is congruent to LO. You mark that using dashes, okay? So we checked off this congruence. So this is a pair of sides. I'm going to put an S with a circle, okay? So right now, if I think about the 5 ways to prove triangles congruent, right? I don't think there's any information about right angles and right triangles. So I'm immediately throwing out HL. So I'm thinking it's one of the other 4 involving S's and A's. Right now I have 1 S, okay? So now my job is to take this other piece of given and say something. Well, this is saying that segment LN bisects angle MLO. Angle MLO is right here, MLO. If that angle is bisected, then it is split into 2 congruent angles. So the 2 congruent angles it's split into are this one and this one. So what I'm going to do, right, is I'm going to name those 2 angles using 3 letters each. So in step 2, I'm going to call that top one MLN. So angle MLN is congruent. Now I'll name the bottom one like this, OLN. If you see I'm trying to use correspondence. The point M up here and the point O down there are like the same point in each triangle. You can see that the top triangle and the bottom triangle are just a reflection of each other. So if you remember your reflections. So angle MLN is congruent to angle OLN. And again, the reason we're going to put is because of this word bisects, and it bisects an angle. We're going to put angle bisector. If you want to write down that an angle bisector splits an angle to 2 congruent angles, you can do that. I don't care. Okay? And now I'm going to put an A right here. So that gives us an angle pair. So right now we have a pair of congruent sides and we have a pair of congruent angles. So our job is to find a third thing. Now, side is out the window because side doesn't use any angles. So now it's either going to be angle, side, angle, angle, side, or side, angle, side. Well, now I've run out of a given. So now the next thing has to come from the picture. And if you look at this picture, look at how these 2 triangles touch. I'm going to change color. They share a side. They share side LN. LN is used in both triangles. LN is congruent to itself by reflexive property. So step 3, segment LN is congruent to segment LN. This is going to be by the reflexive property. And now if you look here, there is another pair of sides. I'll put an S. And our job is done. We have 3 of those letters. Now, how do I tell which way the triangles are congruent? Well, let's write that down first. So, step 4. So I know the triangles are going to be congruent. So LMN, not LMO, sorry, LMN, triangle LMN will be congruent to triangle LON. And now, which way is this? Well, if you look, it involves 2 sides. And if you look at where those 2 sides are compared to the angle, or where the angle is in between those 2 sides. These 2 triangles are congruent by side, angle, side. Again, side, angle, side. And there's your first triangle congruence proof. All right, great job. All right, let's do the next one. Okay, all right. Set this one up. So example 2. Okay, so I am given that angle T is congruent to angle R. And I am given that segment QT is parallel to segment RS. Let's draw that picture. So here's our picture. So we'll name this Q, R, S, T, and then we'll draw in segment QS to create our 2 triangles. So there's your 2 triangles. We would like to prove that triangle QST is congruent to triangle SQR. Okay, and again, I'll set up my statements and reasons, and then we'll go from there. Okay, so let's write down the given first, right? So let's start with our proof. So number 1, I know that angle T is congruent to angle R. I know that segment QT is parallel to segment RS. This was given to me. Okay, so next, let's talk about what is congruent. So angle T is congruent to angle R. Notice I used 1 letter each. That's just the vertex. All right, so we have a pair of angles. So I'm going to put an A right here for angles. Okay. Next, what does the parallel lines give me? Well, if I trace the parallel lines, so QT is here, RS is here. And if I trace the transversal running through the triangle, you should see the letter N, or a sideways Z if you turn your head. Remember, because your lines are parallel, alternate interior angles are congruent. Those 2 angles are here, use 2 dashes, and here, use 2 arc marks. Those 2 angles will be congruent. This is step 2. Angle. And I'm going to name this bottom one first. TQS. Angle TQS is congruent to angle. Now T corresponds with R, so I'll name it R. And then RSQ, because S is my vertex, SQ. And again, this is because alternate interior angles. And you could put congruent if you want to. Okay, and I'll put another A up there, because that's another angle pair. So again, of my 5 ways, no HL, because there's no right angles. Side, side, side is gone because it involves 2 angles. Side, angle, side is gone. So now it's either going to be angle, or angle, angle, side, right? Well, if I look at this picture, look at how these 2 triangles touch. They share QS. QS is going to be congruent to itself by the reflexive property. Segment QS is congruent to segment QS. by the reflexive property. And now I'll put an S there. Okay. And now the question is the side in between the angles or is it not? Well, if I look at where the two angles is, this is in between the angles. So that means that TQ would have to be the side marked congruent, and it's not. So it is not angle, side, angle. It's going to be angle, angle, side. So step 4, triangle QST is congruent to triangle SQR, and that is by angle, angle, side. And we are done. Okay, 2 down, 1 to go. Last, but certainly not least. All right. So example 3. So we have given segment XY is congruent to segment ZY, and segment YX is perpendicular to segment XZ. Right? So you got to know what these symbols mean, right? That upside down T means perpendicular. All right, let's draw the triangle. So I'll draw kind of a taller triangle like so. Let's call that X, Y, Z, and then we'll have Y, W going straight down. And there's W. Okay, and we are trying to prove that these two triangles are congruent. We're trying to prove that triangle XYW is congruent to triangle ZYW. Here's my statements. Here's my reasons. Okay, let's jump right into the proof by writing down all of our givens. So we are given that segment XY is congruent to segment ZY. We are given that segment WY is perpendicular to segment XZ. That is all given to us. Okay, so the congruence, X, Y, Y, Z, Y. So there's a pair of congruent sides, so I'll put an S there. Okay, now we need to know that this upside down T means perpendicular. Right away, you need to know that perpendicular lines, I'll use the upside down T actually. You can write the word perpendicular, I'm not going to. So perpendicular lines form right angles. So we are looking to see where WY and XZ intersect. So WY goes straight down, XZ goes straight across. They intersect here at W, which means that the two angles at W, this one and this one, are both right angles. So in step 2, I'm going to name those two angles and say they're right angles. So angle, I'm going to use 3 letters, XWY, that's the angle on the left, and angle ZWY, that's the angle on the right, are right angles. And now, if you think about our proof, when you have right angles, we now need to think about HL. So I'm going to scratch off this S for a second, because now, if we have right angles, we have right triangles. So I'm going to say that triangle XYW, just using the naming up here, and triangle ZYW are right triangles. And that is because right triangles have one right angle. Okay, so now that I've established that these two triangles are right angles, if you look at this picture up here, these two segments, X, Y, and ZY, the two segments that I was given are congruent, are actually the hypotenuses of the right triangle. Again, if you trace the right angle and draw an arrow, it points to the hypotenuse. So now our job is to prove that a pair of legs are congruent, and we can use HL. Well, if you look at how these two triangles touch, they share WY. Segment WY is congruent to itself. So step 4, segment WY is congruent to segment WY. And that is by the reflexive property. And there is a pair of legs. We've established that we have right triangles. We have proven the legs congruent, or a pair of legs congruent. We were given the hypotenuses are congruent, so we are done. So step 5, hopefully you can see this. Triangle XYW is congruent to triangle ZYW. And again, this reason is called HL. Perfect. And we're done. So hopefully these 3 proofs are okay. So you now are going to have a proof card sort as your activity. So again, please come see me, and I will give you the baggie to work on your card sort. Hopefully do it in a group. Okay. All right. Thanks for watching.